Okay, quick summary. Alpha is the rate of change of omega, all rates of change with respect to t. Alpha is the rate of change of omega, omega is the rate of change of theta. So if you know alpha and delta t, you recognize alpha as a rate of change, and you write down what that means. Alpha is change in omega divided by change in t, rate of change of omega with respect to t. You can then, if you see it, if you know alpha and delta t, you know this and this. Multiply both sides by delta t, you solve for delta omega. I just realized today people don't understand that you're multiplying both sides of an equation by the same quantity. I commented on how the SOL forces instructors and teachers to teach mathematics by visually, sort of. And that doesn't translate well into more advanced mathematics, so be aware of that. And I'll give you some material on the rules of algebra and how you've been applying them when you don't really necessarily know it. Okay, well anyhow, so then if you happen to know theta, omega, and delta t, you immediately see, okay, omega is a rate of change, let's write out what that means. That means omega is delta theta over delta t. Now you understand that if you also know delta t, you know two of these three things, and you can solve the equation for the third one, which is delta theta. And we pretty thoroughly discussed all that. And then having found delta theta here and delta omega here, you can add your delta omega to your omega. What's delta omega? It's the change in omega. It's how much omega changes, so you add that to your value of omega, and you get your new value of omega. And if you know how much theta is and how much it changes, then you know how much it's going to be. You're going to find your new value of theta. Okay, those are all pretty straightforward individual concepts, but in an unfamiliar context, once you get used to it, it all becomes actually fairly simple, and it comes down to something like this. Okay, if you have a rule for finding alpha, which is something we assume from the context of this discussion, if you have a rule for finding alpha, and you know your values of omega and theta, what can you do? You can use a small time increment delta t, calculate alpha. Now you don't need the delta t to calculate alpha. In this case, alpha, the rule was just alpha equals negative 300 cosine theta. Okay, so you know theta, so you plug that in, cosine of theta multiplied by 300, and you've got alpha. So we can calculate alpha just from the rule for finding alpha. And then we can find from that delta omega, because alpha is your rate of change of omega. Multiply that by your delta t, you get your delta omega. And you can find delta theta. How's that? Well, omega is the rate of change of theta. So you multiply your omega, which you're given, which you know, by your delta t to get delta theta. And then, knowing the change in omega and the change in theta, and knowing what omega and theta are, to start with, you can add the change to the quantity and get the new values. And you can also get a new value of t, because t is going to increase by whatever delta t is. Well, at that point, now you've got a value of theta and omega, and you can come back up here and you can calculate alpha based on those values of theta and omega. And then you can do the whole process again. You get new values, you feed back here, you go through the process, you get new values, you feed it back until you've got what you want. That's the scheme. And I'll say this isn't exactly what I did in class because the camera had cut out before I got to write any of this down. So this is really what I'm trying to summarize.